Hi there, we just released new features and new functionality to our UBOps SaaS platform in this release 2.23. And in this video, I will walk you through what we added and where you can find all the features, plus how to work with them. So what we added in this release was a beta version of support for training on UBOps. More about that later. We changed a little bit how environments work in UBOps, so I'll also touch upon that. We added CPU and GPU utilization to the logs of every request so that you can see how much your CPU or GPU is actually utilized during a request. And lastly, we added some handy utility functions to our client library to help you debug and test stuff locally before you push it to UBOps. So without further ado, let's start with training. So as I mentioned earlier, training is still in beta, so it might be that some things don't work exactly as how you expect. Please let us know if you find anything or if you have any feedback, because we expect to be releasing a full version of this sometime soon with added functionality as well. So how does training on UBOps work? At the moment, it is already possible to run training code on UBOps, but we never really had a proper flow for it. So we added that to it now. So what you will see is that in the left sidebar, there's now a new page added called training. When you go here for the first time, you will see that you need to enable the training functionality before you can use it. So if I click on this, that will prepare everything in the background to make sure that I can actually start using training. And how training works in UBOps is basically by creating experiments and creating runs. So an experiment is basically a collection of experimentation runs of different pieces of training code that created different model artifacts that you might want to compare with one another. So let's just create our first experiment together. If I click create new here, I can give my experiment a name. So let's say I want to predict or classify Pokemon's primary types based on their images or on how they look. So let's call this my Pokemon experiment. And then I can give it a description. So classifying Pokemon's primary type based on their appearance using TensorFlow. Okay. Then when I go down here, I can select what kind of environment to use for this experiment. I can select hardware, so if you have GPUs enabled, you can toggle them on here and also select what kind of GPU to use. I'll just do it on simple CPU for now. So let's increase our instance type to be a bit bigger. And then we can select the code environment to run in. So an environment is set for your entire experiment. So every run will take place in the same environment. So if you have any requirements that you need, this is the place to add them. So let's create a new environment together for this one. So I'm going to call this my Pokemon TensorFlow environment. And I'm going to base it on Python 3.8. And then what I can do here is in the custom dependencies section, I can upload my requirements.txt file or my UBOps YAML specifying any additional libraries I want to be installed in this environment. So let's click upload file. And then I've got here a training environment zip prepared, which just contains my requirements.txt with things like TensorFlow, NumPy, etc. And if I hit save, this will now be the selected environment. And then I can continue. I can select what kind of default output location I want to use. So when I'm doing some training runs, I'm creating different artifacts and maybe some plots of the loss and accuracy over time. I want to be able to save them in a specific place. So if I have any additional buckets that I created, I can specify that one here, and that will make sure that everything you output in terms of files in your training runs will end up in that bucket. But I only have the default bucket in this project, so I'll just use that one. Now, if you need to use any environment variables in your code, you can also put them in here. They work exactly the same as for deployments. And lastly, we've just got some labels. So let's add a label here. And then when I click create, our experiment is created. And now we can create runs for this experiment once the experiment environment is done building. So what this is doing in the background is, because we created a custom environment, it's just installing all the dependencies, preparing this environment that we can start using for all our different training runs. And if we go to the logs, we can also see what's happening in the background. So what you can see is that it's like installing a bunch of different requirements based on what I specified in the file. Okay, so now that our environment is ready and our experiment is completely prepared for our runs, we can start to create our first training run. So let's click Create Run. We can also give our run a name and a description again. So let's say I call this the training run for Pokemon with let's say 3 epochs. Then I can specify the maximum duration. So if I have a certain timeout I want to take into account, I can specify that here. That's especially relevant if you're using expensive hardware like A100 GPUs. Then it might be nice to set a timeout just to make sure that if something goes wrong, it won't continue running for too long, eating up your resources. For mine, I can just keep it like that. Then I can upload my training code. So this is a Python file that contains your training code. I will show you in a bit what's in mine, but let's first upload it. So I'll upload it to the default bucket. There's my files. Here's my train.py. And then I can specify what training data I want to use and any additional parameters I want to pass. Now, it's important to note that this training data is not mandatory. If, for instance, you have all your training data stored in like a relational database, you can also simply set up a connection with your database within the training code and load your data directly from there instead of passing it explicitly like this. So this field is not mandatory, you can leave it as is. But in my case, I will upload a zip file with my data. So I've got a zip file containing a bunch of Pokemon images. So I'll upload that. And then I can specify any additional parameters I want to use in my code. This can take the form of any type of dictionary. So just any kind of parameter you want to use in your code, just make sure you also pass it when you create the run and you can use it. So in my code, I am using the number of epochs I want to use. So let's say I put that to 3. And I also specified the batch size that I want to use, which I'll put to 32. And now with all that filled in, I can just click Create, and this will start my training run. So while my training run is going on in the background, let me quickly show you what's actually in the code that I used. So here I've got the code that I uploaded earlier. So this is that train.py. It has a function called train, which takes as input training data and parameters. And this is basically the format that we need, and it needs to have a return statement with the following fields. So we need to return an artifact, metadata, metrics, and any additional output files that we need. It's good to know here that none of these output fields is actually mandatory, so you can leave the ones empty that you don't use. So in my case, for instance, I didn't have any metadata to output, so I just returned an empty dictionary. But these are essentially the fields that you can play with. So what I'm doing here is nothing too special. I'm just reading in the training data that's being passed to this function. I'm preparing my TensorFlow image data set from this, and then I just train a typical TensorFlow model on this. I specify the layers that I'm going to use, etc. And I do some evaluation in which I make some plots of the loss and accuracy over time, which I also want to output because I will be using that in the evaluation of my model. So I'm outputting that here in the return statement. And as you can see, when you look at the artifact I returned, I also specified in this case, for instance, what bucket to put it to and how to rename the file once it's in that bucket so that I can make sure everything is stored in the right folder. Okay, so if we now go to the web app again to check how our run is doing, what you can see is that as the run is going on, is running, you can see the real-time logs being streamed on this page so that you can keep track of what's actually going on. And if anything looks a bit funky, you can cancel the run. In my case, it completed now, so I can view the full results. And here I can see the metrics that I've got and the output artifact with a link to it. So if I now want to use this in a deployment, for instance, I can just go to this model file and make sure that I load that in any kind of the predictive deployment that I want to use. And that's basically how training works for now. As said again, this feature is still in beta, so if you have any feedback for us, don't hesitate to let us know. And we also kind of already touched upon the environments a little bit here. So in the experiments, you can create a new environment. We did the same for deployments. So right now, if you have a deployment and you create a new version, what you will see is in this deployment package section that now there's no longer a drop-down called language, but there's a drop-down called environment, and you can select what environment to use. So here you've got a selection of the typical base environments that we already had, so like the Python 3.8, etc. And any custom environment you created for your experiments will also be available here to use, so you'll be able to select them from the drop-down. Other than that, the workflow for you stays exactly the same. So if you upload a deployment package that contains a requirements.txt or UBOps YAML, any kind of dependency information, we will create a new environment for you based on that information and whatever base environment you selected here. So nothing really changes in the workflow for your deployment. It's just a change in the back to make sure that our cold starts are less and also that the build times are a lot less than what they used to be. Another thing we added is some handy utility functions that we added to the client libraries. These utility functions are mainly for improving how you can test your deployments locally and how you can validate if everything will work before you push it to UBOps, so that you can catch errors early before needing to wait until your deployment is actually finished building so that you can test it. So what we added are a utility function for running your deployment locally that simulates how UBOps would run your deployment so that you can check if that works. We also added a function for validating your requirements.txt and a function for validating your UBOps.yaml, just so you can check that everything's properly formatted before sending it over so that you can debug it locally already. Here I've got an example notebook just to show you how the new functions that we added to the client library actually work. So I'm just importing our latest version of UBOps, and then what I'm doing here is the first one is to validate a requirements.txt. So I can grab this function by doing ubiops.utils and then using the validate requirements file and passing any kind of requirements.txt file I have. So let's just run this and then you can see it. So if I run that, it will start validating every single line of my requirements.txt. If it sees anything that's weird or funky, it will throw an error or it will print what the problem is. But in my case, everything's fine, so it will just return true. We've also done the same with a YAML file, so you can do the exact same thing, but then using ubiops.utils.validate YAML file and passing the path to your YAML file to validate that one as well. And then we added another function for running your deployment locally, just so you can check if your code actually works before you push it. So in my case, I just have a really simple dummy deployment that just takes numbers input, multiplies it by 2, nothing special. So I can run that by using the ubiops.utils run local function and then passing the path to my deployment package and passing in the data that I need to use. So if I run that, you can see that it starts initializing the deployment, is printing all the print statements that are in there, and it returns what the output is. So if anything were to be wrong here, you would also see any errors logged in here. And that's basically an overview of it. Of course, we will put examples of how to use this in the release notes as well, so you can check it there in your own time. And that's actually all I wanted to share with you today. So thank you so much for watching, and let us know if you have any feedback, of course.